Alrighty, CNT140, we're looking at Chapter 3 on fiber optic communications. Here, the focus of this chapter is going to be kind of why we use fiber and applications for. Some of these we've talked about before and looked at before, but some might be new areas or applications that you haven't thought of. Beginning the chapter, they remind us about the amount of data that fiber optic can carry. The big advantage is it can carry more information longer distances in less time. So therefore, in many cases, it's the most cost-effective means for transporting information. Picture back from the 70s shows this is a large pair bundle of phone lines, copper phone lines, and this is showing you that this single strand of fiber can carry all of that data, if you will, giving you kind of a visualization of the quantity of data that a single fiber strand can carry. And with this, because of the bandwidth and distance capability, fewer fiber optic cables are needed, fewer repeaters, amplifiers, those sorts of things, and therefore less maintenance. So with that, goes back to the whole, it can be a lot more cost effective. Fiber, we should also remember, is not affected by electromagnetic interference, EMI. So in industrial environments with a lot of electrical lines and motors and conveyor belts kicking on and off, robotic arms kicking on and off kind of thing, those magnetic fields around those devices will not affect the data moving across the fiber optic cable. Fiber is also lighter than copper wires, so in some applications, airplanes, automobiles, that sort of thing, it can be the media of choice, if you will, to reduce the weight of. With this, has led to this being the transport medium of choice for your data transmission, phone transmission, voice transmission, those sorts of things. Both your telecommunications companies and cable TV operators use fiber for these reasons. And there's been a lot of migration over the years of copper lines to the house slowly being replaced by fiber up to or near the house and potentially even to the side of the house, in places of businesses and homes. Converting from copper networks to fiber and vice versa is actually pretty easy through use of a media converter. This is similar to the style I showed you in the lab room. Here's a media converter here that we would have a fiber signal coming in this side, converted to copper going out, or vice versa. And I could repeat that on the other end with a media converter. And I can connect two pieces of equipment together that don't have fiber ports with the media converters. Modern switches come with SFP slots, allowing us to slide an SFP module into that open slot. And then I can plug a fiber cable directly in between our two switches here. That is something we'll do in a lab very shortly here in our semester. We will actually connect some devices together with fiber optic links. And you'll see that all I need is these little transceivers, this little SFP module, to give me a fiber port to connect the two switches together. Telephone networks were the first major use of fiber optics, replacing those copper links, giving you a longer distance between the central office and a box out in a neighborhood, if you will. This is where the fiber optics started becoming used first in your telecommunications. This again gave you more bandwidth and distance and more cost effective because one fiber strand instead of 128 copper wires. Then they started using to connect their central office long distance switches. That's kind of what I mentioned there, but also going from the central office to long distance switch going to another city. These started getting replaced with fiber optic lines. A lot more bandwidth, a lot more distance, a lot more equipment needed to move that signal from place to place. Then your phone companies started replacing the shorter links between switches with fiber, and eventually, like we said, to your house in many cases. Fiber line the whole way out to your house. And this is kind of what they're showing you here, fiber to the home. So fiber optic from the central office out to maybe a box in the neighborhood, and then a fiber line to each business or home. And then there's usually a converter box at the, if you have fiber to the home, a converter box in maybe the garage or the basement that converts it into copper for use inside your house. So getting fiber the whole way out to basically the edge of the business or the home. Cell phone networks have fiber backbones. Yeah, there's a lot of fiber connections from your cellular company switching office out to the antennas and back. Again, a lot more distance, a lot more bandwidth capability. The internet as we know it, a lot of this is fiber optic. Again, originally across phone lines, and then quickly being replaced with fiber optic lines as the technology progressed. Those phone lines started getting replaced with fiber optic lines, and a lot of our internet runs across those fiber optic lines now, the vast majority of it. Initially, cable TV networks, if I look on this side over here, this was traditional, was a lot of coax bus topology. That was, and I think they mentioned that a little bit later in the chapter, for many people thought to be very unreliable. Well, the reality was all it took was maybe a tree going down here, and the cable TV for that whole neighborhood, a whole street, whole neighborhood would be interrupted. So initially, coax bus out to people's homes. And as fiber optics start getting used more, a lot of that started getting replaced from the head end out to maybe a neighborhood, and then coax maybe to individual houses. So a lot less coax being used, and then eventually to fiber to the side of the house and convert to potentially coax inside the house. And this is what they talk about. For a long time, cable TV had a terrible reputation for reliability, and it was because of that structure we mentioned. So then cable TV started doing the hybrid fiber coax network. Fiber out to a box in a neighborhood and maybe coax to individual houses kind of thing. And we started getting this structure here, and a lot less interference or interruptions from a tree going down and so forth, a lot more reliability. And then eventually having fiber to the home, and here's your coax fiber, this part over here, fiber to maybe the neighborhood, and then coax to your house, and copper inside kind of thing. But they are starting to get fiber to the side of your house as well. Our premise networks, the main use of fiber optic on a premise networks is those backbone connection between switches. And I think I have that on the here, that backbone connection between the closets, between the switches. That's the main use for fiber optic. Again, I can get longer distances, higher bandwidth between my closets, and then I can do copper to the desktop. That was very traditional, in many cases still used. And here again, fiber backbone with copper to the desktop, exactly. Fiber connecting my two closets together, my two switches together, and then copper structure that we've been dealing with all semester, patch panel out to outlets, and then copper to the desktop. That sort of thing right there. So in that structure, my switch here, these would be all copper ports for copper to the desktop, and then over here an SFP slot that I can plug my SFP module and my transceiver into, and that would allow me to connect my two switches together, like we had in the structure back here. SFP here, fiber line to SFP here on this switch. Now, if we want to start doing fiber to the desktop, I might change the type of switch I'm using. This is a type of switch that has 24 SFP slots, allowing me to have a fiber line going from here out to the desktop area. So I would have my fiber switch here running fiber lines out to the desktop area, and I would use a little converter, a little transceiver to plug the fiber line in here, and a copper patch cable to the desktop computer, if you will. So the structure starts looking like, I think I have it down here. Oh, I have it down here a little bit later. We'll get to that. But that's the basic idea with fiber to the desktop then. So this can be possible in implementing a fiber switch here, if you will. I can get rid of this area here where I would have the switch that goes from the fiber to the copper. I could get rid of that piece here and run fiber the whole way out to the desktop, just using this little media converter to convert that fiber link into a copper connection for the desktop computer. Many people in businesses now are using laptops and wireless devices, so it's really, in many cases, only the high-end data users that are maybe the high-end computer and data users are the ones that would need the hard connection, if you will. So that's what they're saying here about fiber to the desktop can be a viable choice. A lot of users are using wireless. I can use a couple dedicated high bandwidth links to the desktops that need it. Again, going fiber out to the desktop here and using a media converter for a desktop or a media converter for access point kind of thing. So again, my structure in the closet, I would have a fiber switch, SFP if you will, in there. That fiber line runs down, partway into the building to potentially a fiber patch panel. Okay, potentially a fiber patch panel here, allowing me to interconnect. And then that fiber line goes out to the desktop area with your media converter here, and giving you fiber to the desktop. So very doable. So I took all those pieces and kind of put it in one graphic here for you. Switch here, fiber switch here, fiber line potentially out to a patch panel here to interconnect, and then out to the desktop area where I have a media converter here converting the fiber to copper connection at the desktop. The advantages of doing this type of thing is that I'm not limited to the 90-meter distance of copper to the desktop area. I don't need those switches in the telecom closet. I don't need additional switches and equipment here. I can have a passive patch panel. Okay. I don't really need a telecommunications closet. This could be a cabinet on the wall or a cabinet in the corner of a room. I don't need to have a dedicated closet, if you will. It would not take up much space. And this is really similar to your fiber to the home equipment that we would be using. Your optical LANs use passive optical network architecture, fiber to the home. With this, a lot of times you're using single mode fiber that's capable of bidirectional, meaning I can send one signal going out to the desktop and device and another signal coming back across that single fiber. Now it does take special equipment to do that, but it is possible to do that. Typically less expensive overall than the traditional structure of copper and so forth. Other uses for fiber optic security. I think we mentioned this before. Security cameras, we have a greater distance to be able to cover, especially if I'm dealing with an area like, I think they mentioned here, like airports and so forth, large buildings, airports. I can run a fiber line a long distance to a security camera. And I actually have, in some cases, if I'm using a bidirectional link, the ability to pan or tilt the camera. So giving me some additional capabilities here. So fiber the whole way out to my cameras. And I can do a converter here if I need to plug into a copper link. Metropolitan area networks used for fiber optic, again, surveillance, connecting public service entities, fire, police, so forth, hospitals, schools, and even traffic management systems. And some cities are even burying conduits that they can use later to put fiber optic in, so you don't have to dig things up later. Industrial, we mentioned this earlier about industrial environments have a lot of electrical noise, so fiber optic can be a good choice there for immunity to that noise. So when I'm dealing with manufacturing plants, assembly plants, so forth, if I look at all the electromagnetic interference around these devices, the fiber optic line would be immune to that, to go out to those fiber optic, to those robotic arms and so forth. All you need to really do is, install maybe a breakout cable to go to all these devices, and there is rugged fiber optic that would allow that. I might only need media converters for the local connection. I might only need that for doing this. Utility networks are using a fiber optic as well, obviously for security and that sort of thing, network management, but sometimes they're actually installed in lines, high voltage lines, and that can carry data, but it can actually be leased off to other providers or other businesses, if you will, that need a high bandwidth connection. Also allowing monitoring of the systems. So I can monitor whether there's a failure or there's a break and so forth. They mentioned military. Yep, a lot of data moving around, and it's immune to jamming, interfering with the signal. Airplanes, immune to noise and so forth, and a lot lighter weight. Same thing with automobiles as well. A lot of automobiles can use fiber optic because, again, it's a lot lighter and immune to all the interferences. And then they talk about designing fiber optic networks, knowing the standards and so forth to do this. So there is our Chapter 3.